What if the universe was never supposed to exist? What if, in the first moments after the Big Bang, everything should have destroyed itself, but didn't? That single question has ignited one of the deepest debates in modern physics. According to the laws of physics, the birth of the universe should have been violent and brief. When the Big Bang occurred, matter and antimatter should have formed in equal amounts, and when matter meets antimatter, they annihilate each other completely. If that balance had been perfect, nothing would remain. No stars, no planets, no life. And yet, here we are. A physicist affiliated with Harvard has drawn attention to this mystery, pointing out something that still troubles cosmologists today. Matter survived, even though it shouldn't have. This tiny imbalance, where matter slightly outweighed antimatter, is known as Baryon asymmetry. That difference was incredibly small, but it was enough to shape the entire universe. Because of it, galaxies formed, stars ignited, and eventually, life emerged. The question is simple but unsettling. Why was the balance not perfect? Some scientists argue that this imbalance happened by chance, driven by physical processes we haven't yet discovered. They believe future theories or experiments may one day explain exactly how matter gained the upper hand. Others look at the same numbers and feel something different. The mathematical precision required for matter to survive is extraordinary. If the balance had shifted even slightly in the other direction, the universe would be empty. To some thinkers, this level of fine-tuning raises philosophical questions about intention, design, and meaning. It's important to be clear, this argument does not scientifically prove the existence of God. Science works through testable evidence, repeatable experiments, and measurable data. Questions of purpose lie beyond that boundary. This discussion belongs to the philosophy of science, not experimental proof. Still, the mystery remains untouched. Why does the universe exist at all? Why do the laws of physics allow anything rather than nothing? Science is remarkably powerful at explaining how the universe works. It tells us how particles behave, how galaxies form, and how time itself unfolds. But when it comes to why the universe exists, that question remains open. And perhaps that question, unanswered, vast, and deeply human, is what keeps us looking up at the stars, searching not just for equations, but for meaning.